Hello students, in this lecture we will discuss one more problem. Student, this is a problem from our NCERT textbook, page number 208 and example number 12.5. It's a solved example. Let's read this question first. Resistance of a metal wire of length 1 meter is 26 ohms. 26 ohms at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Student, what is given to us? Resistance of a metal wire of a length 1 meter. A conductor is there of length 1 meter. The conductor have a resistance of 26 ohms and the temperature is 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, if I draw the wire like this, say suppose this is the cylindrical wire we have, the diameter of the cylindrical wire, this is the diameter of the cylindrical wire is 0.3 millimeter. Length of this wire is 1 meter and surrounding temperature is 20 degrees Celsius. So this temperature is of no use for us. If the diameter is 0.3 millimeter, what is the resistivity of the metal? Now students, resistivity, we have to calculate the resistivity. Student, here are the given conditions. Resistance of the wire is 26 ohms, length of the wire is 1 meter, diameter of the wire is 0.3 into 10 to the power minus 3 meter. Why this 10 to the power minus 3 meter? Because 1 millimeter equals 10 to the power minus 3 meter. Now this is not a SI unit, so we have to convert this into SI unit. So we have converted this into SI unit by multiplying 10 to the power minus 3. We want to calculate the radius. So radius will be half of the diameter, and that's 0.15 into 10 to the power minus 3. Student, we have to calculate the resistivity. Now here is a formula to calculate the resistivity. Now to calculate the resistivity, this is the resistivity, this is the resistivity. To calculate this resistivity, we need the resistance, length and area. Now students, see, we are given resistance to us, length is also given to us, area. So nowhere in this question area is mentioned. That means area is not given. But to calculate this resistivity, we need the area. That means before we calculate the resistivity of this wire, the first task is to calculate the area of this wire, the cross-sectional area. This cross-sectional area we have to calculate. Now student, if this wire is cylindrical wire, you can understand, you can imagine what is the cross-sectional area. What is the cross-sectional area? It's a circle. So we have to calculate the circle's area. So cross-sectional area. Cross-sectional area A. Now student, cross-sectional area is pi r square. That's the area of the circle. The value of a pi is 3.14. Radius we know it's a 0.15 into 10 to the power minus 3 and it's whole square. If you simplify this, you will get the value of area like this. Now students, now we have an area. We can use this equation. So here is the equation. We want to calculate the resistivity. So a little bit of a rearrangement will give us this, and substituting the appropriate values, resistance value is 26. Area, will substitute the value of area from here. This is the area. The length is 1 meter. So we'll substitute the length as a 1. Now student, if you simplify this entire number, you will get the product like this into 10 to the power minus 6. So here is the final answer. Resistivity of 1.8369 into 10 to the power minus 6 ohm meter. Okay students, let's start. This is a problem from our NCERT textbook, page number 208, problem number 12.6. Student, here is a question. A 4 ohm resistance wire is doubled on it. Calculate the new resistance of the wire. A 4 ohm resistance wire is doubled on it. Calculate the new resistance of the wire. Student, we have a wire. This is the wire. This wire is doubled on it. Now, what is the meaning of doubled on it? That means if we have this wire, we will bend it from the middle so that the new shape of the wire becomes like this. The wire will look like this if we bend it, if we doubled it. That's what we mean by this word doubled on it. That means from this middle part, we will bend it this way. So if we bend this wire from the middle, means we'll double it. So our wire will be looking like this. So let's start the first case. We'll divide this problem into two cases. First case before doubling and second case after doubling. So let's say, suppose we have a wire of a length L. The cross-sectional area of this wire is A. And according to question, the resistance of this wire is given to us. It's a 4 ohms. And now student, the second case, because we have doubled this wire on itself, so the length of this wire will be half, because from the middle only we doubled it. So the length of this wire will be half. Now see, the area becomes double. We started with the area A. Now because we have doubled it, so area becomes twice A. So this is the new case. So in this case, what will be the resistance? What will be the effect on resistance? So we have to calculate this new resistance. So student, now we know resistance is equal to rho into L by A. So in this case, the first case, resistance is given to us. It's a 4 ohm resistivity, and the length is, let's say, L, area is A. Let's say, suppose this is equation number 1. Now second case, student, if I apply the same equation, R is equal to rho into L by A to this case, so resistance, this is what we have to calculate. Resistance will remain same because the resistivity will not change. The wire is same. We didn't change the wire. We simply changed the dimensions of the wire. So the resistivity will not change. Resistivity is independent of its dimension. So resistance will remain the same. Now length has become L by 2. Length will be half and area has become twice, doubled. So if I simplify this, rearrange this, we will get 4A. Let's say suppose this is equation number 2. If I divide both these equations, dividing 1 and 2, you can take any of this LHS and RHS in the numerator part. So let me just take suppose 4 divided by R. So LHS is divided by LHS, and now RHS of the first is divided by the RHS of the second. So you can see here this rho and rho can be cancelled. If I simplify this part, RHS part, we will get our equation like this. So this L and this L can also be cancelled. This area can also be cancelled. So we are left with 4 by R is equal to 4 by 1. So if I cross multiply and rearrange this, we will get the equation like this. The value of a resistance is a 1 ohm. Now students, you might be thinking why we have divided here. Now students, when we are simplifying any equations, we must always think about reducing the variables. So here we have number of variables. Rho is a variable, L is a variable, A is a variable. So we have to think about reducing the variables. So the only way out to get rid of all these variables is dividing. If you divide this, now you cancel this. So if you cancel this, so you have no variable except R, the required variable. So that's why we've divided it. We could have followed this another way also. If you don't want to divide it, we can proceed another way. Now students, pay attention. So this is the two equations. Without doing this step, we can move this way also. 4 is equal to rho into L by A. This is the first equation. Now R is equal to 1 by 4 rho into L by A. Look close. This 1 by 4, here 1 by 4 is there. So this 1 by 4 we can take out. So if you compare these two equations, this part is nothing but equation number 1. Rho into L by A. Rho into L by A. Now I can substitute the value of rho into L by A as a 4 here in this equation. So see, we have 1 by 4 into 4. If I substitute the value of rho into L by A equals 4 here, this 4 and this 4 can be cancelled and we will get the value of resistance of 1 ohms. So that's how we can solve this problem. Students, I hope you understood these two problems. Thank you.